Hi there, guys. Welcome. It's my pleasure. Take a seat, take a cup of tea. Unfortunately, I don't have any at the time, but just behind my back. And as soon as I'm done with this video, I will for sure enjoy a wonderful cup of tea. So go ahead, pause the video, and do yourself a favor and enjoy some great tea. Because that makes my heart go boom boom. Oh, so such a stupid joke. All right, folks. Today's about two things. First thing is Jupyter Notebooks. When to use them, how to use them, what are the benefits, and what are the disadvantages. The second thing is about data types which contain more than one value. So lists, sets, dictionaries, tuples. Those four are built in, and we will cover all of them. So just in a very basic. So this is a basic tutorial. If you know this stuff too well, then make yourself a tea and just enjoy the afternoon or whatever time it is on your side. But if you don't know what about this is, what are the advantages, disadvantages, and when to use them, stick around. I guess it could be interesting for you. So let's start. Jupyter Notebooks. Those are, if you missed that, if you never knew what Jupyter Notebooks were, then it's a shame. But it's not a big deal either. So let me say this. Jupyter Notebooks are quite a hyped topic in the Python community. They're everywhere. If you do one single let's say a machine learning course on Coursera or wherever, you will for certain get to know Jupyter Notebooks. And Jupyter Notebooks are a great way of doing prototyping stuff. They are at the core a mixture of markdown cells and code cells. And markdown is a way of describing your text that you can read it in a text editor, but you can also just transfer it into a more Word-like document or LaTeX-like document. So this is the main benefit of Jupyter Notebooks. If you just look here, for example, you have code cells, print hello, and you have here a text cell, which is just a hashtag heading text, and then with the $sign you're in the math environment, and in the math environment it's all, you can do stuff like the Pythagoras in here. So this is it, more or less. Not that impressive, but you can build impressive things with it. If you just go to the Jupyter homepage, you see it here. You have different figures. You could have sliders where you can change the parameters, which then interact with the code cells, and then you can interact with it. For prototyping, it's perfect. It's not perfect to build a program. And that's what many guys get confused. But if you want to do yourself a favor and want to learn more about why it's not a good idea to do your whole program, your whole thing you want to publish someday in a Jupyter notebook, just go ahead and watch this video. This is one of the most hilarious videos I've watched in quite a while around this topic. From Joel Grus, I don't like notebooks. It's so awesome because this guy is very, very funny, and but he has really some valid points about this, and I don't remember all of them. Go ahead and watch this video. It's a good laugh, and it's also some valid points. All right, so this is it. Now, second thing, the data types which contain more than one value, right? So if you just do a quick search, you will get something like this. This is what I found really helpful on this page. You see here list, tuple, set, and dictionary, and the difference between them. We will get into all of them. The list is more or less the most common way of doing multiple values in with one variable, but it is changeable. So you can add stuff in, you can remove stuff out, it's ordered, so you can get the second element or the fourth element if it exists. Then it's mutable, you can change it, and yeah, I think that's about it. This is very common. So lists are used always, all the time. So for example, if you want to maybe let's build a small example, right? Let's build a small example in a Jupyter notebook, because it's fun. Jupyter notebooks are fun for this thing. So let's say a equals 2. So just to be sure that we are on the same page here, this is a assignment. The variable a gets the value 2 assigned to it. Okay, so that means 2 is written into the variable a. You have to read it from right to left. 2 is stuck into variable a. Now, if I print a, I will get the value, which is 2. So far, so good. Now, if I want to have a list, I could say, for example, a equals 2, 3 with this bracket. Now, this is a list, and I forgot to print it. All right, you see 2, 3. So far, so good. Now, if I want to add another value, I could say a dot, I'm not sure, add will work, or is it append? Append will work for sure, but I think add should work as well. Okay, it doesn't. So append it is. Append 4 leads to a 4 being here in the list. So you see, pretty important that you get this right. You see that the list is not determined how long it is. Okay, can be made longer, can be made shorter, and that's one thing that pretty bad for memory allocation, because you must know the program doesn't know how much RAM to accommodate for this. So how many bytes should I reserve in the memory for your variable? I don't know this, but for a set, for a set or a tuple, it's defined because they are immutable. I don't know how it's worded. It's not mutable. It's immutable, I think. Oh, where it is. Advatages. Okay, search it. So tuple is immutable. Set is also immutable. It's not immutable. Oh, it's mutable. Immutable means that you cannot change it. Cannot change it. It's fixed in length and values. You cannot change it. That means that as you assign the variable, the program, the compiler, knows already how much memory to account for. Okay, so 32 kilobytes. You're done. You will never ever need more than 32 kilobytes. But for a list, it's not defined. And that's why it's not a good idea, memory-wise, if nothing changes. That's where tuples are better. Now we have the first really difference between those two. So lists are perfectly if you want to add stuff to it, change it, make array operations. Array operations are kind of sketchy term here because it's not an array. You have a NumPy array, but it's sort of an array, you know? So it's not an array in NumPy language, but it's a sort of an array because it's a list of several values, which you can run through. Or you can just do a for loop and add something to it. Let's see how this works. Let's say we have a empty list. And we will say for I in range 4. I just recognized that range also yields into a list, because this is what the range function does, but never mind. A.append I. What does this mean? This means for every I in the range from 0 to 4, append this I value to the list A, which is an empty list at the beginning. So 0, 1, 2, 3. That's what I'm expecting. And I will not see it if I'm not printing it. So, oh, I'm sorry. Should not be there. Okay, so I'm typing an A here, and you see 0, 1, 2, 3. So for stuff like this, lists are perfect, right? Do stuff like 21, whatever you see, and you can make so-called operations with lists. Perfect. Sets, on the other hand, if you know that nothing changes ever with these values because they're fixed, then a set is better because memory-wise doesn't need as much as memory. Can you change set at all? Yeah, you can. Yeah, you can. Let's define a set. How is a set defined? A equals, and now you have the curved brackets. 1, 2, 3, 4. Okay, print A. So far, so good. Now, if I do stuff like this, let's see. Change it, right? Now, first it was 1, 2, 3, 4, and now it's 1, 2, 3, 4, 5. I changed it. But by doing so, I just erased the whole value in the memory, completely gone, and just wrote the whole stuff again into the memory. And that's really bad. That's not memory efficient. Because for a list, you would have just to add this into the memory, but now you're just erasing this and writing this. And that's why it's not so good. Not so good idea. Okay, basic stuff. You have you don't have operations like add or remove for a set because it's not changeable. But as I forgot to tell you, for a list you also can remove something. 1, 2, 3, 4. Oops. Let's see. This is this, and then we want to remove a.remove 4, for example, and then print a again. Okay, you have to do the print command because only the last one is printed out. Be more correct. You see, 1, 2, 3, 4. You remove the 4, and then you're left with 1, 2, 3. All right, that's okay. Remove is a perfect example, but there are different ways of removing, right? You can also do something like A with the brackets again, and then 3. What the hell? That's the same thing. Why? What is this? Okay, let me explain. So you have here the variable name A. This is referring to the list, and then followed by these brackets. And those brackets tell this variable that it has to go to a certain index. The list has indices. First index is 0. Second index is 1, so the count starts at 0, 1, 2, 3. So A with the brackets 3 just points to this variable value, to this value. If I want to remove the third value, ta-da, no 3 anymore. And if I want to print a single value here, I'll do something leads to an error. This index is not there anymore because I removed one. Now the list gets one shorter than the third index, which is 0, 1, 2, 3. Not there anymore. So list index out of range. This is a common error. I get this all the time. All right. Yeah, back to it. Let's do it like 2, and then you get the 4 because you removed the second index. 0, 1, 2. This is removed. And now I printed the second index. 0, 1, and because the 4 moved 1 up, it's the 4 again. Alright, that's out of the way. Then let's see. Lists, tuples. We now come to sets and dictionaries. Well, sets are most oftenly used just to when you don't want to have duplicated values. You know, let's say you have a list of IDs and the IDs are unique. But because you didn't code properly or you cannot really make sure that the ID is not seen twice in the data you examine, you use a set to record all the IDs, because sets don't allow for duplicate values. Lists does, tuples does as well, I guess. I'm not 100% sure, but the perfect example here is we can try it. See, let's build a tuple with a duplicate value 1, 1, 2. What do you think? Okay, duplicate is here. But let's build a set now. Set is built with curly brackets. The curly ones. Don't you like curlies? 1 and 2. You see, but there are 3 values. 1, 1, 2. Where's the second one going? No duplicates. No duplicates. That's why you just have 1 and 2. And that's pretty cool, because in here, it's like the ID 1 is seen twice in this. But you don't want this to happen, and that's why you have the 1 and 2 only with a set. Perfect. So sets are used for this. There are different ways to use set as well. So, but I want to tell you just the very, very basics, that you get a understanding on how each data type works and how you could use them. But you will get this over the time. You can also look here in the code and learn about it more in this link. I will post this in the description because it's a really good link, gives you a good overview over the things. Now the dictionary is a pretty cool thing. Dictionary is like, imagine you're going to a hotel and there's a receptionist and you ask him or her, well, I would like to get to the room 420, right? And he hands you or she hands you the key for the room 420 because you booked all the rooms. And you go there and you see what's in there. So this is sort of a dictionary. Dictionary has keys and values. And the values can be anything, and the keys are the unique identifier to get the value. So dictionary, you know, let's just take a dictionary from the bookshelf and look what's with the word, whatever, banana. What's that meaning in Swedish? I don't know, but you know, it's a unique translation. You have a unique word. It makes no sense to have the word twice in your dictionary. You have just one. This is it's a picture. So keys and values. Think it if you have a calculator and you have those save spots where you can save your variables, your lists. Dictionary is sort of a safe spot for your lists because you can assign certain keys and then put, for example, lists in there. And if you want to later get back to this list, you just get to the dictionary. Yeah, for this key, I want a list, and you're done. So let's make an example. I know it's a bit complicated. If you hear this for the first time, you think, oh, this guy is going nuts. But let me show that to you in an example. Let's say I have 2 lists. A is, let's not call it A. Fruits is, my favorite fruits are for sure bananas, because I'm an ape. Bananas, apples, whatever, I don't know, lemons. And now let's make a separate list. Cars I want to drive, right? So for me, it will be definitely a Mercedes, forever, I don't know, Audi, or a BMW, whatever. 2 lists. And I want to, so those are my favorite cars and fruits. It's nonsense, but stick with the example. Now I make a dictionary to save this. The dictionary, I call it my dict, is equal to, now you have the curly brackets again. And with the curly brackets, you now just assign a key and then a value. And you do this by separating those twos with a colon. So, let's say I have a string as keys, or string data type for keys. So my fruits, my favorite. English or American, I don't know. Let's make it American today. My favorite fruits. And now you have a column. And you have the variable fruits. Now, comma, and my favorite cars. I don't, car brands. And you have the cars. This is it. So you have this key, which points to this list. And you have this key, which points to that list. This is the thing. This is the way. Okay, now I just print it. You see, this is printed like the dictionary. So pretty much like this. With your key and your value. And now let's assume you want to add another car, because recently Elon Musk has maybe built a new super roadster and I want to try whatever. And I want to add a favorite car brand. So how do I get it? I'm not sure really. I would have to Google it. It's embarrassing. But you have my dict, and now how do you get it? I don't know. This is really sketchy, but I don't know really. That's I have to do this all again, but maybe it works. Yeah, it does. Okay. You have to accept my apology for this, because I'm switching all the time around between Java and Python. And sometimes it gets getting a little bit of confused. So what is set here is I have the dictionary here. I want to get to the room my favorite fruits, and there the fruits await me. So I say, okay, I want to get this list. So this is the list, right? So the list. Don't use list as a variable name. This is my list. Now I could add something to my list. For example, well, I wanted to do the cars, but no, never mind. So my list get a value, and whatever, pineapple. Okay, so this is appended, and now I want to print my list, which sure has pineapple, right? But if I now print dict, does it have it or doesn't have it? This. Sorry, my English speaking skills are still improving. But you know, do you think that the dictionary got this change, or didn't it get it? Didn't it get it? I don't think so. I don't think it got it, but let's see. Now we have to print my list again. I'm sorry. Print my dict again. It got it! Oh my god, I can't believe it. And now here's a pretty damn good example of calling by value and calling by reference. I changed the my list. But my list, what? This is assigned here. But it's not assigned by value, it's assigned reference. Just gets a pointer to it. So let's assume you have your hotel room, and there is a banana, an apple, and a lemon. And now I said, all right, I want a favorite fruit, and pineapple should get added to it. And this is what I'm telling here. Now, because it's done by reference, this command sends the hotel manager or whatever sends him to do a pineapple into the room where my favorite fruits are. That's what he's done. And print my list is just doing, all right, what's in that room? But the room has changed, as you can see here. The dictionary now has in this room bananas, apples, lemons, but also pineapples. So if you want to do a operation which is just within the context of this scope of this variable, you have to do it as a copy. And I don't know how to do this. I would have to Google it. But you have to copy it. Let's see how to do this. Copy list Python. You see, list.copy. Pretty straightforward, right? let's do that. Let's do that. List.copy my dict get. This should work. And now you see it. You see it. So did you saw it? Did you see it? You have the list here, which has the pineapple, but the pineapple is gone here. So what you did was you told the hotel manager, all right, go to the hotel room, make a picture, a copy, and bring me that picture. And in the picture, you cut something out, a pineapple, and just stamped it on here. So your list, your photocopy of it, this has a pineapple, but the hotel room didn't see any pineapple. And this is a really important thing, and you see me stumble over it, right? So I just thought, yeah, because in Java it's done otherwise. But here in Python, you have this thing that you have to copy it. If you just want to do local changes to this list and not affect the dictionary, be careful about this. Now, we covered sets, we covered tuples, dictionaries, lists, and not just because I prepared it and never showed it, and it's kind of stupid, but I want to show it anyway. This is how you define it in your code. So you have lists. This is the normal brackets, or I don't know how to call them, the brackets. And you have for value separated with commas. Tuples with the curved brackets, sets with the curly brackets, and dictionaries also with the curly brackets, but here you have to do the pattern key, colon, value, and then comma, if you have more than this. But now let me think. Where do I use this? Which applications can we use? It's used all the time. All the freaking time. Because if you make changes to a data set, it's more often than not done on a whole bunch of things and not just on one variable. And there lists come into play. And then maybe you want to save something like in a dictionary. Dictionaries are so common. You know JSON, the data structure, how the web is built up. JSONs are just dictionaries because in a JSON file you have keys and then you have dictionaries again. That's another great topic here. You have nested things. You can have a list of lists, of lists, of lists, of sets, of dictionaries. You can have it all. And you can intertwingle them. So in a JSON file, you have dictionaries of dictionaries of dictionaries of dictionaries. And at the end, you have values. But this is a whole data structure. And be sure to use the built-in functions you have here for your programs, because this is a basic start. With those 4, you can do pretty damn good stuff. If you do more matrix operations, then you want to use NumPy arrays. Look into the pandas in the pandas package. Some stuff as well. Some data files. Yeah, data files. It's called data files. Data frames. Data frames. Also pretty important topic. But this is more sort of a basic introductory video where we just covered the 4 basic ones, and those 4 basic ones are here listed here. I've been going over the differences here. You can just take a quick glance if we covered everything. So list non-homogeneous. This means that the data types, they don't have to be the same in the list. You have an integer and then a string next to it. Then a data structure which stores the elements in a single row and multiple rows and columns. Yeah. Tuple, non-homogeneous data structure which stores single row and multiple rows and columns. Set data structure, also non-homogeneous with key. All right, this is all covered. Okay, you have the signs. This is the normal bracket. Up how do you call it? But those are brackets, curved brackets, curly brackets, and yeah. Allow duplicates. Sets do not. And here also because it's a set, more or less, you don't have duplicates. Yeah. Also duplicated keys don't work because let's see, you have 2 rooms in a hotel with the same room number. That leads to some, not non-wanted scenarios, I guess. Okay, you have nested all along. Nested means lists and lists and lists. And examples, we did plenty of examples here. And you can create this also with those functions like list, tuple, set, dict. This is also a good thing to know. So list is mutable, tuples are immutable, set is mutable, so you can change a set, but no duplicates. And a dictionary is also mutable, so you can also change the list, which is assigned to a key. Other person, other fruits, whatever. Ordered, ordered, unordered, and ordered. Yeah, unordered because you with the duplicates. And this is also very important. You also have to initialize a value, a variable, an empty list, for example, if you want to do this, for example, as we did with the for loop. So you cannot just do something like for a in range or list punct. List is a bad example. My list dot append I. This will not this will not work because my list is not defined. But if you do define it here, my list equals, and you have an empty list, then I did a typo here. And then it works, but no output because I did not include one. Print my list, and there you go. So this is called initializing of a variable. So you're assigning an empty data type to it, and this is what's been said here. Creating an empty list, creating empty tuple, empty set, and empty dictionary. That's about it. So if you want to learn more, visit the site, look to the code. You can also copy the code into your own Jupyter Notebook. Also try out a, I don't know why this is not working. Try out a Jupyter Notebook. You can just try it in your browser. So you can play around with it, see if that's something for you. And if you want to go and do this more frequently on your home computer, you just install Anaconda. We have made a video about this, how to do this. And then you have a Jupyter right away. You can just search it, press enter, and that brings you here. Then you can create a new Python 3 notebook, and boom, you can do your thing here. All right, thanks for watching, guys. If you have any questions, comments, please let me know. I would be very happy if you leave a like, a comment, or a subscription to our channel, and take care. Until next time.